Welcome to Lesson 1.5, Describe Angle-Pair Relationships. So we're going to begin with a few different definitions in order to be able to describe and apply these different angle relationships. So the first piece we're looking at are complementary angles. So complementary angles are two angles, so a pair of angles who add to 90 degrees. So sum being addition. So two angles who add to be 90 degrees. Supplementary angles are two angles whose sum is 180 degrees. So two angles who add to be 180 degrees. And our third definition and pair of angles that we're going to look at are adjacent angles. And adjacent angles are two angles that share a common vertex and a side, but have no common interior points. And what's considered the interior of an angle, if we're looking at angle 8 here, the interior would be this part inside of the two rays. So in between the rays and the vertex. So angle 7, our interior would be here. Our exterior would be anything out here. So in order to be adjacent, they have to share a vertex. So the vertex is the point where the angle begins, where the two rays begin, share the endpoint, and a side. But they cannot have common interior points. So some examples. Complementary angles, so the ones that add to be 90 degrees. An example of adjacent complementary angles, we have the box symbol here in the corner, meaning right angle, and the two angles, 1 and 2, add to be 90 degrees, and they're adjacent because they share this side, but they don't have any shared interior points. Non-adjacent complementary angles would be like 3 and 4 here, so they don't share a vertex and side, but they still add to be 90 degrees. Then supplementary angles, so they add to be 180. Adjacent supplementary angles would be like 5 and 6 here. Added together, they make a straight line or 180 degrees. They share this ray here and a vertex. So 5 and 6 are adjacent. Non-adjacent would be like 7 and 8. They don't share a vertex or a side, but they still add to 180, which makes them supplementary. So now that we have those three definitions, we can start to apply them to different diagrams and algebraic pieces. So in example 1, in the figure, they just simply want us to name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So in part A, complementary angles are the angles that add to be 90 degrees. So we'd have angle RST and angle BAC, so 58 and 32 equal 90. Supplementary angles add to be 180, so we'd have angles CAD and RST, so 122 plus 58 is 180, so just checking the math on the side here. And then adjacent angles would be angle BAC here and CAD here. They share the vertex A and the side, which is ray AC. Then in diagram B, our complementary angles are the two that add to 90. So it'd be angle FGK right here, and then angle GKL right here. So FGK, GKL, 41 and 49 equal 90. Our supplementary angles are the two that add to 180. So our angle of GKL, 49, and then HGK, or KGH, which is 131. So 49 and 131 equals 180. And then our adjacent angles would be angle FGK and KGH. So the two that share the same vertex of G, and they share this side, GK. And then question C. Question C asks, are angle KGH and LKG adjacent angles? So we're looking back at this diagram here. So our KGH, so this one right here, the 131, and LKG, the 49 adjacent. Well, right away, they don't have the same vertex, so no, they're not adjacent. Then it asks our angle FGK right here, 41 degrees, and FGH, so FGH being this whole larger piece here, so the 41 and the 131 together, are those adjacent angles? So yes, they share a vertex of G, they share a side, but they have common interior points, because FGH contains all the points inside of FGK. So they cannot be adjacent angles. Example 2 says find the measures of a complement and a supplement. So we know complementary angles equal 90. So if I'm looking for a complement, that would be the angle that completes the equation to solve whatever the other angle is, plus this equals 90. So we know in example 1 here, to find the complement of angle 2, they gave us, to find the complement of angle 1, they gave us the measure being 68. We're looking for angle 2, so we know measure of angle 1 plus the measure of angle 2 is 90 degrees, because they're complementary. So 68 plus the measure angle 2 is 90. So then 90 minus 68 tells me angle 2 must be 22 degrees. Then in part B, dealing with the supplement, meaning supplementary angles, so they add to be 180 degrees. So we know the measure of angle 3 and 4 add to be 180. They gave us the measure of angle 4 being 56 degrees. They want us to find the supplement angle 3. So angle 3 plus angle 4 would give us 180. So the 180 minus 56 gave me angle 3, which is 124 degrees. So simply put, to find a complement, you do 90 minus the known angle. To find a supplement, you do 180 minus the known angle. Now on to page 2. Example 3 is applying the idea of supplementary angles to this diagram. So when viewed from a side, the frame of the ball return net forms a pair of supplementary angles with the ground. Find the measures of angle BCE and the measure of angle ECD. So BCE, this angle here, they gave to us as 4x plus 8. And then angle ECD, this one back here, was x plus 2. So 4x plus 8, and then x plus 2. So the first thing that we want to do is find x. So we know those two angles added together are 180 degrees because they're supplementary. So I take 4x plus 8 and the x plus 2 and add them together to be 180. Then combine like terms. 4x plus x is 5x, 8 and 2 is 10. So 5x plus 10 equals 180. Solve for x, so we subtract 10 on each side. Then we're left with 5x equals 170. Divide both sides by 5, and x equals 34. So then we have our variable of x being 34. We can substitute 34 into both expressions for our two different equations to get their angle measures. So angle BCE was 4x plus 8, so that becomes 4 times 34 plus 8, 136 plus 8, or 144 degrees. And then angle ECD was x plus 2, so 34 plus 2 is 36 degrees. And then our 36 degrees plus 144 equal 180, so we're good to go. So example 4 is just showing the simple way again to find a complement. So they tell us angle 1 and 2 are complementary, and the measure of angle 2 was 8 degrees. Find the measure of angle 1. So 90 minus the 8 degrees will give us 82 degrees. Then in part B, they tell us angles 3 and 4 are supplementary, so they want us to find the supplement. And they tell us angle 3 is 117 degrees. So we'll do 180 minus 117, and that gives us 63 degrees. And then part C. They tell us angle LMN and angle PQR are complementary angles. They want us to find the measures of the angles, and they told us LMN was 4x minus 2, and PQR was 9x plus 1. So because they're complementary, I know the two angles added together equal 90. So I can take the 4x minus 2 plus the 9x plus 1 equals 90. Combine like terms, and we have 13x minus 1 equals 90. Add the 1, then divide by 13, and x equals 7. So then we can substitute that 7 into both expressions to solve for our different angles. So angle LMN was 4x minus 2, substitute in 7, and we get 26 degrees. In PQR, we're also substituting 7 in for x, so 9x plus 1, 9 times 7 plus 1, 64 degrees. 64 plus 26 is 90 degrees, so we know that's correct. So we have our two complementary angles. Then moving to our other two definitions for angle pairs, we have a linear pair. So a linear pair are two adjacent angles whose non-common sides are opposite rays. So the angles in a linear pair are always supplementary, meaning they equal 180 degrees because if they have opposite rays, those form a straight line. So an example of a linear pair would be here, angles 1 and 2. They share a common side and vertex, and their non-common sides make our opposite rays. Then we have vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays. So in this case, we have this red line and blue line, and angles 1, 2, 3, and 4. So angles 1 and 2 are vertical angles. Their rays form two different pairs of opposite rays. And then angles 3 and 4 are also vertical angles. So the simple way to think of vertical angles are if you make an X, they are on opposite sides of that X. So they're on top and bottom in this case, or left and right together. And another note is just that vertical angles are always congruent to each other. So angle 1 and 2 are congruent, and angles 3 and 4 are congruent. Then example 5 asks us to identify all the linear pairs and all the vertical angles in the figure at the right. So we're looking at this figure here. We have two different sets of linear pairs, angle 1 and angle 4. Right here, these two angles together share the common ray, share a vertex, and make a straight line. And then also angle 5 and angle 4 across the bottom here. Together, they make a flat line, and they share this common side. And then our set of vertical angles, we only have one pair, which would be angle 1 and angle 5. Together, one set of opposite rays, two sets of opposite rays. So that's our only piece that is vertical angles. So example 6 tells us two angles form a linear pair. The measure of one angle is 5 times the measure of the other angle. Find the measure of each angle. So we could create a diagram to show this scenario. So we know it's a linear pair. One angle is x, the other is 5 times x. So we can set it up algebraically. X plus 5x equals 180. 6x equals 180, divide by 6, and x equals 30 degrees. So we know one of our angles is 30 degrees, the other is 5 times x, so 5 times 30 is 150. So our two angle measures would be 30 and 150 degrees. Then example 7 says use the figure at the right to answer the questions. So we're looking at this figure here. So first part A says, do any of the numbered angles in the diagram form a linear pair? Explain. So no, we do not have any linear pairs. No two angles share a vertex and add to be 180, with that shared vertex being on opposite rays. For part B, which angles are vertical angles? We have three pairs, angle 3 and angle 6, angle 1 and angle 4, and angle 2 and angle, is that 3? Nope, that should be a 5. 2 and angle 5. So that right here, my apologies, should be angle 2 and angle 5. So we'll want to change that to a 5, not a 3. So then those three sets are vertical angles because they share a vertex and their sides form opposite rays. Then in part C, it says the measure of an angle is twice the measure of its complement. Find the measure of each angle. So because it says complement, I know I'm dealing with 90 degrees. So one angle is x, and the other is twice that amount, or 2x. So x plus 2x equals 90 degrees. Then 3x equals 90. Solve for x by dividing by 3, and x is 30 degrees. So I know one of my angles is 30 degrees, and the other is twice that amount. So 2 times 30 is 60 degrees. And then our last notes for today are already written out for you, but just some pieces to highlight and make sure you understand. So a lot of geometry comes down to interpreting and reading diagrams. So there's some different things that we can conclude from different diagrams and some things that we cannot. So for example, looking at this first diagram here, This bullet pointed list are all things that we can conclude from this diagram. So first, looking at this diagram, the way it's drawn, we can just automatically assume those points are coplanar because they didn't draw any other planes, they didn't write any other notes, so we assume they're coplanar. We can also conclude that points A, B, and C are collinear because they're drawn to be on the same line. We also can then say that point B is between A and C. The definition of between in geometry, which we'll explore more later, is that a point is on the same line and then it is on the interior of those other 2 points. We can also conclude that AC is a line, BD is a ray, and BE is also a ray, and that they all intersect at point B. Then we can also conclude angle DBE and EBC, so DBE right here, and then EBC right here, we can conclude that those are adjacent angles, and we could also conclude that angle ABC is a straight angle or a flat line. And then we also have point E lying on the interior of angle DBC. So angle DBC, point E here would be considered on the interior. But then there's also some things we cannot conclude. So looking at this original diagram still, we could not conclude that segment AB is congruent to BC. They look like they are, but without the symbols drawn, we cannot say that they're congruent. We can also not say that angle DBE is congruent to angle EBC. So DBE and EBC look like they may be congruent, but we don't have any symbols or measurements, so we cannot say that they are congruent. We also cannot say that angle ABD is a right angle. Again, it looks like it's 90 degrees, but they don't give us any symbols or measurements, so we cannot say it's a right angle. In order to conclude any of those pieces, we would have to be given the symbols like in this diagram here. So this diagram would have to be updated to look like this in order for us to conclude these statements. Then the hash mark on AB and the hash mark on BC mean they're congruent. The little arc on angle DBE and the arc on EBC mean those are congruent. And the right angle symbol right here tells us ABD is a right angle. So without those symbols, we cannot conclude those pieces. So again, going back to the main idea of today's lesson, the main idea are these angle pair relationships, which boil down to complementary angles, supplementary angles, adjacent angles, and then linear pairs and vertical angles.